So let's start with a short, let's say, survey about servers. You know, those metal pizza boxes that you use to run your enterprise software on. Who loves them? Who loves servers? Who hates servers? Who has no idea why I'm asking this question? That should be the rest of you, right? Yeah. So we're not going to talk much about servers today. Even, you know, if you're doing serverless, then still there's going to be servers, but you just don't care about them as much. Another question: what do we see on the background here? Where is this taking place? Well, we know that Maarten, who is sitting on the front row here, is also sitting on the front row there. So that's a cue. No, it's not Devox. It is close. Well, it's closer to Antwerp than where we're here. Yes, it's JFOL. So this is the largest Java conference in the Netherlands, and the app that I'm going to talk about is the backend for the conference app for this conference. Oh yeah, so I forgot to turn on my sound, which is good because I want to do a sound check. So let's try it again. What are we hearing? Okay, good. Sound is working. That's good to know. So my name is BERT JAN SCHRIJVER. I'm CTO at OpenValue, and I'm in the board of the NLJUG, the Netherlands Java user group. I'm going to share some of the stuff I did for the NLJUG in the past 10 years, almost. Not full time, maybe 1 day per year, but still, a period of 10 years. So the NLJUG is a Netherlands Java user group. We are quite a large Java user group. We have about 5,000 members, around 100 business partners, and we organize a couple of conferences. JFOL here being the biggest Java conference in the Netherlands, about 1,800 people on a 1-day event. If you've never been there, I can recommend to go there because it's a great event. So at JFOL, we are using an app, the NLJUG Events app, that attendees can use while they're at the conference. This was created by the Dutch tax service. So if there's anyone in here who pays tax in the Netherlands, thanks a lot for your financial contribution to this. So how does it look? You can pick any conference. So we organize a couple of conferences per year. Once you open this, the conference, there's some background information about the conference. You can see sessions, you can see information about speakers and sessions, and most importantly, you can rate sessions, which is pretty much the same as in the Devox mobile app, right? So you can give anywhere from 1 to 5 stars and leave some feedback for the speaker. So the architecture for this, it's an iOS and Android app. This is connected to the internet. It gets all the static content, so JSON files with session descriptions, speaker images, a map of the venue, gets it all from AWS S3, which is an object store, and then votes for sessions are being sent to an app backend. We're going to talk about this backend now. So the initial version I created together with the Dutch tech service about 10 years ago. This was a traditional Java EE application running on Wildfly 8, Java 7, Amazon EC2, so virtual machines in the cloud, a load balancer up front, and then connecting to MySQL running on Amazon EC2. Pretty normal, I'd say, for 9 to 10 years ago. So when I was building this, I was working with Tim, the guy on the left here at the Dutch National Police, and I showed him this architecture, and he said, "But you're doing it all wrong." And I said, "Why, Tim? Why am I doing it all wrong?" And he said, "Yeah, this is the ideal use case for a serverless application." I said, "Why? And what do you mean?" He says, "Well, it's an application that has no load during the year and peak load once, 2 or 3 days in the year." So I said, serverless, what does it even mean? Well, with serverless, we're typically talking about functions as a service. So you're not deploying entire huge applications, but you're deploying functions or small applications. It's also called FAS. They're typically short running, so maybe even handle 1 request only or 2 or 3 requests. So there are small units of execution. They're on demand, so you're only paying when you're using. Typically, there's like a pay per request model, or at Amazon Lambda, you pay for CPU memory megabyte, like CPU seconds and memory megabytes what you used. They scale back to 0. So if there's no request, they'll scale back to 0 and you're not paying, which is ideal for an app that you're only using once or twice a year. But since we're scaling back to 0, startup time matters. So to start up a JVM and maybe a Spring application on there, we're talking at least a couple of seconds, and maybe even like in the order of magnitude of 10 seconds. So if you were to vote in the NLJUG app for a session, you need to wait for 10 seconds, so I'll be gone after 3 seconds already, right? So startup time matters for cold starts. So a cold start is app is scaled to 0, request comes in, then the app needs to start up, then it processes the request, sends a response. Typically these apps, they don't shut down directly after a request. So they typically stay alive for like 15 minutes or something. So if you then get the subsequent request in, there's a warm start and it will behave pretty much the same as you'll be running on like a regular always on machine. There are still servers. So for those of you who love servers, good news. For those of you who hate servers, also good news, because they're still servers, but you don't need to matter about them. So serverless means there are servers, but they're outside of your view. So my first serverless experience is in 2016. I got an Amazon Echo. I got it from the UK because it was not available in the Netherlands at that time. And then I wrote like Amazon Echo, I don't know what it's called, app or something. So this was some Java code. I need to implement an interface, write some text, compile it as a jar, upload that jar via the browser to Amazon, and there it will be deployed and run. And this is how it looked.
Alexa, tell me what's the best day?
Wednesday is the best day, of course. Friday is alright, but not as good as Wednesday.
That's amazing, right? So this is my first serverless experience. A couple of years fast forward, the tech service asked me if I could take over the development and the maintenance of the app backend. So I built it in something that I was comfortable with at the time, which was Spring Boot 2, Java 8, and the infra was pretty much the same, still running on EC2 virtual machine, so Linux boxes, a load balancer up front so I could horizontally scale the application. And I switched to AWS DynamoDB as a database. So DynamoDB it's a key value store basically. You can see it as a NoSQL database. You can send keys and values in there. It's kind of like MongoDB, but a bit different. At that time, it was sort of serverless, so it's a managed database, like you would get any database in the cloud. You still needed to configure how many read and write units you wanted to have for the database. So I still need to do some tuning there. Nowadays, it's fully auto-scaling. You just say, I want a database, here's your database, and it will scale according to your needs. So this worked all fine, but the downside was that this is always on, and that costs money. So it's a bit of a waste if you have, I don't know, like a load balancer costs 35, let's say pounds, 35 pounds a month. EC2 instance, depending on the size, costs anywhere from a couple of tens of pounds per month to a couple of hundreds. So if you're only using this 2-3 days a year, you're not going to get like, I don't know, 200 pounds of AWS cost every month. So what I did is every time before the conference, I would set this all up, and after conference, throw it away again. Not that much work, but a bit of a pain. And then I couldn't use the application to, for example, retrieve votes from the conferences through the rest of the year. So I'd built this and deployed this, and was still working at the police at the time. Happily showed it to Tim, and Tim said, "But you're doing it all wrong." I said, "Why, Tim? It's Spring Boot 2, it's Java 8, this is modern stuff in 2018. No, because this is the ideal use case for serverless. You should look into serverless computing." I said, "Okay, you got a point there." So my first attempt at serverless with actual like precision code was at an open value hackathon somewhere in Belgium. So we were there with the team, and I was trying out. At that point, GraalVM native images were like relatively new. And I got my first GraalVM native image running on Lambda. So the point with traditional Lambdas at that time, you would deploy Java code or jars there. And when a request would come in, you'd still need to first start up the JVM and then whatever code you have been running there. So that could easily take like a couple of seconds, which for impatient people like me is quite long. So it is also possible at AWS Lambda, which is Amazon's serverless runtime, to deploy a custom runtime. And this is basically a single binary that you deploy that runs in Amazon Lambda and will get started up whenever a request comes in. And GraalVM native images allow you to take some Java code, compile it into a native binary. So a Linux binary that runs in AWS Lambda that will start up whenever a request comes in. So now you're only limited by the startup time of this single binary, right? So I'll dive into this more in the rest of this talk. So at this point, I used, I think, a Vertex and compiled a native image, run it there, and it worked, but it was slow. So first of all, I had a Mac x86 machine, and Amazon Lambda was running on Linux x86 or something. And there was not really good tools available to like cross-compile via Docker. So how I did this was type my code locally, start up an Amazon machine, copy it there, compile it, download it again, upload it again. Well, kind of a pain. So a bit more about GraalVM. It's both a Java development kit and a Java virtual machine. Oracle builds it. There's two options to use it as a runtime. So first you can run it as a Java virtual machine, where it's based on hotspot VM, and there's just-in-time compilation. So how many of you are capable of explaining JIT? Okay, well, let me do it for you. So just-in-time compilation is a mechanism in the Java virtual machine that will, well, let's say, continuously analyze your code that's being executed and optimize it on the fly. Basically, so that the longer your application runs, the more tailored machine code instructions get basically derived from your Java code. So this is awesome, and this is also one of the, I think, the marvels of engineering in the JVM, right? The JIT compiler. You can also run with ahead-of-time compilation. And then you're compiling a platform-specific native image binary. So this is a mouthful. What you're doing is some of the stuff that the JIT is doing typically when your application is running, you're putting this all the way forward. So you're doing this all at compile time. So you're doing all kinds of optimizations during compile time. And then you're compiling it to a specific target platform. So for example, Linux x86 or Linux ARM into a single binary. And this binary is basically a Linux binary. So just if you in your command line you would type, I don't know, PS or something. This is also a Linux binary that getting executed. So the nice thing is if you build native images, then you don't need a JVM anymore, because it all gets compiled into one binary. So the stuff that's typically in your JVM and your application, that all takes time to start up. This all goes into one small native image binary. So in the meantime, while I was still learning about Quarkus, freaking Tim is presenting at DevOps Belgium about Quarkus and Lambdas and native images. So he had gotten sick of saying to me that I need to do serverless all the time. He'd caught up and I was doing stuff with Quarkus. So this made me interested in Quarkus. What can I do? So, well, it's Kubernetes native, Red Hat develops it. It's open source. You've probably all heard about it 1,000 times, at least at this DevOps. It's designed to work with everything you have in the Java ecosystem, and it's tailored to run both on OpenJDK Hotspot and on GraalVM. And the developer experience is pretty cool. I'll show you more in my demo in a bit. So my second serverless attempt. Well, there was something like a pandemic in between, so I didn't need to have any conference app backends for a couple of years, but I went back at it at 2022. And there, I think things had pretty much improved quite a lot. So the Quarkus development experience, how fast GraalVM native images were, etc. So then I created like a simple skeleton project that allows you to easily build REST applications that run on AWS Lambda that compile to GraalVM native images. But there was one caveat. I had a new Mac, and it was an M1. And this is ARM processor architecture. And AWS Lambda at that time was supporting x86, like Intel architecture. So how did this work? I needed to, since you're building for the target platform, I needed to build a Linux x86 binary on my Mac M1, which is possible in Docker containers, but then you're emulating basically the Intel x86 instruction set on your ARM M1. And this is super slow, like 30 minutes to compile a native image. I'm way too impatient to wait 30 minutes on one build, right? So, well, that's how far I got. And then I think, okay, this is not really it yet. Maybe I need to get like a Linux x86 machine so I could do this faster, or have a build server, but I kind of got stuck there. But then my third attempt, which was last year in the summer, it finally clicked for me when I saw that Amazon was now supporting ARM runtimes for their AWS Lambdas. So now I could build on my machine, my Mac machine, in Docker, Linux Docker container, an ARM64 binary. So I didn't need to emulate those CPU architectures anymore. And I was pretty fast. So now I could build a native image in like a minute or so on my laptop. So this is on June 10th. And then in June 14th, I migrated the app from Spring on virtual machines to Quarkus native images on Amazon Lambda, which I thought was pretty nice. It was fairly painful. So Tim is finally happy. I don't know who the guy on the right is, but let's not talk about him. So the third iteration of the app backend, well, the boxes pretty much look the same as they were before, right? DynamoDB is unchanged. Instead of a load balancer, I now have an API gateway. Instead of Spring, I now have Quarkus. Instead of a JVM, I have GraalVM. Instead of Java, I know 8, and I have 17, and it's running on AWS Lambda. So if you zoom out enough, every architecture diagram looks the same, right? Most of the components are different, but the general ideas are the same. So the gateway takes all requests, forwards it to the Lambdas, and then Amazon basically auto-scales the amount of Lambdas you need to handle the amount of requests that you see getting in. I'll wait a bit for your pictures to finish. Did you get me for my good side, Maarten? I'll share the slides on Twitter and X afterwards, so you'll be able to grab them there. So it's time for a demo. We're going to well, basically build a Quarkus GraalVM native image Lambda API gateway image from scratch. So let's start. What do you do if you want to start? Well, you look in the docs, right? So let's have a look at the Quarkus documentation. One remark, I am running on my mobile phone's hotspot at the moment, so stuff may be a bit slower than usually. So we can grab a Maven archetype and generate a Quarkus Lambda AWS REST gateway project. So let's do that. Yeah, now it's scanning the internet if there's a newer version, which may take a couple of seconds on a mobile phone. All right, group ID, well, I don't know, my company group ID. I'm sorry about the EU part if that's painful for some of you. Lambda demo. Okay, so it's generated, so let's go there. Idea. So this is what you get if you generate like a skeleton application there. Let me blow it up a little bit for you. So there's a POM. There's some like the basic Quarkus stuff is in there. There's a Quarkus dependency management thing in there for the versions, and then you get 4 choices of running serverless stuff. So you can do REST easy, so JAX-RS. You can do servlets with Undertow. You can do Vertex with reactive, and you can do Funky, which is like a serverless functions implementation. There's some basic stuff like JUnit, Rest Assured for Test, the Quarkus main plugin. That's basically it. And you get a couple of implementations that are ready to use. So here's the resource, which is JAX-RS. Just says hi. Servlets, if you're feeling nostalgic, there's servlets as well. Vertex, if you're feeling reactive, and Funky, if you're feeling groovy. No pun intended. But this is all there is. So let's open the project that I have created for this, which is like a skeleton project that has just a little bit more than what you were seeing here. So this project, let's see. I need to revert all the stuff that I did to prepare my demo. Let me do that quickly. So I was preparing my demo this morning and nothing worked. It was horribly broken, everything. But luckily I had like 2 hours to fix stuff. That was just enough. So if we look at what's here. The POM is there. The POM is pretty much the same as what you were seeing, but I removed the stuff I didn't need. So now only there's the REST easy stuff in there, and I added REST easy JSON-B for JSON binding to go from Java objects to JSON. There's a greeting resource that's basically the same as that was generated. So it's listed on /hello, and it says hi from NLJUG. There's some scripts in here and some config in here that I will show you later what this means. I'll run Quarkus in the developer mode. So it runs now on 8080, so I can go to localhost 8080. There's movement in someone's house. I heard a ring notification. And it says hello, hi from NLJUG. This is a bit small. Hi from NLJUG. But what if I don't want to say hi from NLJUG, but I want to say, I don't know, hi from Devox? Well, I can just reload, and now it says hi from Devox. So this is how fast the auto reload works in Quarkus, which is pretty nice. Let's see what I got in store for you. I'm going to run a build. So let's get rid of this project and to my GraalVM demo and run the build script. So what this does is, well, it calls a script, and this script says maven package -d native to go to a native image, and it says Quarkus native container build is true. So it now is going to pull in a container, I think from a query, and then build my native image in this container. So this is basically my Linux runtime with GraalVM to build a native image. So GraalVM is already running here, and it has done a Maven build, and it's now doing the ahead of time compilation to basically analyze my app and do everything it needs so it can package my entire app in a single binary that can run on a Linux system. And this takes anywhere around a minute or so, I think, on my Mac M1, which is a reasonably fast machine, but probably if you get like an M3, it will be even faster. Let's see who's faster, GraalVM in compiling or me grabbing a bit of water. Ooh, About the same, right? So I said a minute, it's about a minute. So then there's now in my target folder a function.zip. Let's unpack that so you can see what's in there. There is one file in there, Bootstrap, and that's basically my whole application. So this is what you would typically have in your Java virtual machine and all your Quarkus dependencies, all that's in the single binary. How big do you think this thing is? So there's a function.zip, so there's zip compression. It has all the stuff that you typically need to run a REST application in Java. So everything that will be in your JDK, all the Quarkus dependencies, there's JSONB in there, there's REST Easy in there, my code is in there. What do you think? How big is this compared to a native image? 180. No, we need to go lower. You were talking megabytes, I assume. Yeah. How big would this be if you include the JVM and stuff? Then it would probably be close like 180, right? Like the JVM and all your classes and jars, etc. We need to go lower. Who dares to go lower than 180? 50. We can still go lower. 30. We can still go lower. 22, that's, I think, pretty accurate. 90 megabyte. So this is everything. So this also means that this probably is also going to consume a lot less memory than the 200 megabyte you would otherwise run, right? So let's see if we can deploy this. I have, well, no, let's first see if we can run it locally, right? Because we're not going to deploy to production right away. So let's run local. So this will pull a Docker container, and this Docker container will run my serverless function local. So, well, I need to go to /hello. Now it's unpacking everything. Let's show it here. Unpacking everything inside a container, and you see here the Quarkus has started up, handled my request, and it says hide from NLJUG. So this is the same as you saw here in the JVM mode, but now it's in a native image. So now we can deploy this, and we're going to deploy this to Amazon Lambda with a deploy script. So what does the deploy script do? This script will copy two configuration files that we'll look at in a bit, and it will say SAM deploy. So SAM is the serverless application model, and this is a tool to work with AWS Lambda locally. So it builds on the AWS CLI. So the AWS CLI allows you to programmatically via command line tools interface with the Amazon API. So I have Amazon credentials configured, I have SAM configured, and now I can say SAM deploy and use this SAM native file to deploy. So deployment is running here. And let's look at the config in a bit. So I have a SAM config. This basically says, okay, your stack name, what you're going to deploy, a serverless API, it's going to be in EU West, some other stuff, and then the magic is happening in SAM native YAML. So what's here is it starts with some definitions, and then here it says I'm going to make a serverless function. It's running on ARM64. The runtime is the Amazon Linux 2 provided runtime. It's in my function.zip that we just saw. Max 256 megabytes of memory. Timeout 50 seconds. Some other stuff is going to handle API events that are getting proxied to my serverless function. We're going to make a serverless API gateway. The name references variable that's lower in here. And then some parameters, the stage. So you can have multiple stage on API gateway. And this can be, for example, dev, test, acceptance, prod. I'll just go for prod because, well, YOLO. And then you can have some outputs from the script. So I'll output the gateway URL and the CloudFormation stack name. So CloudFormation is AWS's infra as code tooling that basically you can use to declaratively describe your infrastructure. So SAM generates these CloudFormation templates for me. So let's see how far we are. It's done, and it's given me this URL. So let's see what we see on this URL. Well, nothing, because we need to go to /hello. And now it says hi from NLJUG. So now my Quarkus app is compiled as a native image and compiled via AWS SAM to AWS Lambda, where it runs as a custom runtime. So no JVMs involved here. I'm sorry, we're still at the Java conference, and I assure you there's Java code in there, but the virtual machine is gone now. So let's say I wanted to get logs. I can fetch the logs for my application. How does it look like? It basically says SAM logs and then the stack name. So this will give me the logs from my Quarkus application. You can even see the logo in here, a bit garbled. So if I were to make a couple of extra requests here, 1, 2, 3, and I get the logs, then they may not be there yet because of eventual consistency. But if I try 2 or 3 times again, then it's probably, yeah, now it's there, right? So you can also see that the first request was handled in, let's say, it says here 166, now here, 356 milliseconds. So this was a cold start. But then subsequent requests were handled in 2 milliseconds, which is pretty fast, right? And here you see also some info about the billing. So it billed me for 3 milliseconds and it used 68 megabytes, which is quite little for a REST endpoint, right? So let me show you what it created in the AWS console. So it created a Lambda. And this Lambda is connected to an API gateway. And the API gateway has an endpoint, it has stages, etc. Well, if we ever get to see something from the AWS console, just believe me that it has stages. Let's see. Yeah, so everything was uploaded to S3. So S3 is Amazon's scalable object store. Here's the API gateway. So stages, there's stage prod, and stage prod basically proxies everything to my Lambda. So whatever gets HTTP request gets there, this gets proxied and sent as an event to my Lambda. And basically this will get handled by the greeting resource here. So the nice thing about this is that your local development experience is exactly the same as if you were building a JVM-based app or building a Spring app. But by the use of a couple of tools, you package it as a native image, and then it deploys to Amazon basically for free and runs super fast. So to have a look at S3, where was I? Here. So there's one bucket, and in this bucket, my files were uploaded for the deployment. So here's a template that basically describes the deployment. And here's my binary. That's the 80.9 megabyte binary that gets deployed. So let's see. Do we have everything? Yes. Okay. Yeah. So this is not really pretty, right? This CIG something execute Amazon AWS.com. Let's add a custom domain name because, well, that looks a bit better. So I can go on my SAM config, and I have this already in there. Just need to uncomment a couple of things. We need a TLS certificate for our custom domain, so we can talk HTTPS. We need a domain name. So this is on the API gateway. We're going to configure that it needs to listen to our custom domain name. So we'll handle requests for that domain name. We have a variable. This is the custom domain name I want to use, and in the outputs I want to also output the custom domain name. So now once I've changed the configuration file, I can just run a deployment again. And the deployment will look at which things changed. It's already saying like, hey, the same file already exists, so I'm not going to upload again because I didn't change my binary. I just changed configuration, right? So now it's uploaded the CloudFormation template to Amazon, and it's now going to apply this. And this is pretty similar to how Terraform works, for example. So what it's going to do is going to add a certificate. So I need a TLS certificate. It's going to add a domain name to the API gateway because the gateway needs to listen to the new domain name. It's going to delete a deployment and add a deployment. I don't know why it doesn't modify, but don't really care. So now here it's where we are. We have updated the API gateway stage, and I think we need to wait a little bit for the custom domain name to be added. We can have a look. This typically takes a couple of seconds. API custom domain names. It's not there yet. So now it has created the API gateway domain name. So now it should be there. Don't even have time to drink water. So now the gateway listens to this custom domain name, but we still need to update the DNS. So the openvalue.dev DNS is not pointing to this domain name yet. So it doesn't really matter whether this is in like an external DNS server or somewhere in AWS. We need to update this in this case. Luckily, I'm running on AWS with the DNS for this domain. So probably I could have automated it as well, but didn't have time, we're lazy, etc. So I'm manually going to update the DNS record for this zone. This is the serverless API URL, edit it and say, okay, you now need to point to this hostname. Now we need to wait for the DNS to propagate, and that can take anywhere between 1 second to a couple of minutes. But let's see if we get lucky. So this is the new domain name that's now configured. We're not lucky yet, because now it says, hey, the certificate doesn't match and HSTS doesn't match. Let's try Chrome. Maybe Chrome is already there. So Chrome says, okay, it works. We now need to go to /hello, and it works. So now we have a custom domain name configured, TLS certificate, just like you would do in your regular non-serverless application. But this is trivial app, right? It's only saying hello in a small resource. Can you do stuff like I don't know, JSON serialization in GraalVM native images? Well, let's see. Let's create a new class. Let's call this. Let's assume that we're going to send out speaker information to the app, right? Well, we're on Java 17+, so let's do records. And a speaker has a name and a tagline. All right, I'm going to add it here. Let's add a new resource that will basically give us a dummy speaker as output. So pod/speaker, we're going to do JSON, and it's going to return a speaker, and well, method name doesn't really matter. And let's say return new speaker, me. And my tagline is CTO.value. All right, so I don't have my Quarkus app running anymore, but if I would, this would immediately work there. So I now can go to local, because of the auto reloading, can go to localhost 8080. And now it says that there's an hello/speaker resource. And it's give me a JSON reply now. So now also the from Java record to a JSON reply is in there. Well, let's build and deploy this again. So I'm going to time now how long this takes. So both a build and then a deploy. So in the build, it's going to run the integration tests that are there. Then pull a Docker container, which is the Quarkus Mandrel builder, and now it's going to start up GraalVM and it's going to generate a native image. So we've already seen this. So what it's then going to do is package it into the function.zip and use AWS SAM to upload it to Amazon and deploy it there. So this will take a little bit longer because of my mobile connection, but I'm going to have you guess how long it will take before the new endpoint is available here. So we're talking about Maven build, integration test and unit tests, GraalVM native image build, upload it to AWS, upload CloudFormation to AWS, apply the deployment, update the deployment, and activate the Lambda. We have 18 minutes left, so the maximum time this can take is 18 minutes. How long do you think this will take? You can shout. 2 minutes? Do we think more or less? 2 minutes, pretty fast, right? And I'm on a mobile connection that will probably take 20, 30 seconds to upload the artifacts to S3. It's not there yet, so it's at least like 1 or 2 minutes now, I think, right? We're still getting a 404 here. We're just waiting until we see the answer, right? It's not there yet. We don't have any errors yet, but it is deploying at the moment. Ooh, it's doing something, and we're there, right? So that was, I don't know, about 2 minutes, I think. We'll see the output here. So AWS SAM still thinks it's deploying, well, wrapping up stuff. So it took 1 minute 46. Maven build, native image build, uploading over 5G and deploying. With a faster internet connection, you can typically shave off 15 seconds. It takes 1.5 minutes. So do you need build servers? Well, in a way, yes, but in the other way, in this project, I'm the only developer and the only system administrator. So for me, this is an ideal for like a toy project that still has serious production use, but still. So if we want to get rid of everything, we can run scripts and destroy the world. Well, we need to type the name of the stack so that we are sure that we want to delete, yes, and delete also all the S3 artifacts. So now it's going to apply a CloudFormation template to delete everything, and probably it's already gone by now. Yes. So you see how this can also be a nice way to super quickly deploy hobby projects without worrying about servers or scaling or whatever, and also without worrying about cost, because we'll look at cost in a bit, but it's super cheap. So that's it for the first demo and the biggest demo. About migrating from Spring to Quarkus. So initially it was a Spring app on VMs on a JVM, and now it's Quarkus native image. Why did I migrate? Well, because when I was starting this a couple of years ago, Spring wasn't that far yet in building native images. I think nowadays it's totally doable to build native images with Spring Native, but I migrate to Quarkus because at the time the experience was better. So Spring on the left, typical Spring annotations. There's a service that registers votes, a REST entity where you can post session data, and then it will save stuff and say, okay, you saved it. How does it look in the Quarkus world? Pretty much the same, but then it's JAX REST, right? So we have the @inject to inject the service. Could have used constructor injection as well, but I chose to do this. Then there's a couple of different annotations. We have post, path. I added some security, so there's permit all now also on there. Instead of, in post mapping, you automatically state that you're doing JSON. Here, I stated it here. Apart from that, it's pretty much the same, right? You're just going from one REST controller dialect to another one. Then the REST entity classes. When I first built this, it was on probably, I don't know, Java 8. And at that time, I wanted to learn Kotlin. So I added a Kotlin dependency and used Kotlin data classes for my data transfer objects. When I first wanted to get this working in Quarkus, I don't know, it was a bit difficult to get the JSON marshalling from Kotlin to JSON and get it working just a couple of years ago. So I was looking at this with my colleague Iago, who's kind of like a Quarkus fan, and I said, why not using records? Because you're now on Java 17. I said, no, because I want to get it working with Kotlin. And then I played for like 2-3 more minutes, didn't get it working, tried records, worked right away. And then afterwards he said, are you already on records? I said, yeah, screw Kotlin, well, I'm using Java records now. So they were pretty much out of the box, but it also looks pretty much the same, right? So it's also just like a data class with some fields and that's it. Well, other things I need to migrate. Here's a live video of me looking for other things to migrate. That was basically it. But I was lucky because I was already using DynamoDB. So there was no JPA or anything involved. I was already using an AWS specific API to read and write data to DynamoDB. And this was already compatible with being built in a native image. So to show you how this looks a little bit, I'll open the actual production code for the NLJUG backend, which is here. How does it look? Pretty much the same. I'd say it's based on the same template. In the POM, there's pretty much also the same stuff. Let's see. I added some Amazon stuff because of DynamoDB. Let's see. Yeah, here's the DynamoDB dependency. I have something to configure authentication from a property file. There's Quarkus arc, which is dependency injection. So this allows me to use the @inject. I added the cache for something, some other stuff to connect to AWS. Not that interesting. Let's have a look at, for example, how the session repository works. So this is a repository that will fetch all session data from a conference in memory. So I have a client to interface with DynamoDB. And basically I'm saying here, build a request and then go paginate, fetch all items from the DynamoDB table, filter them client-side in my Java code because I was too lazy to filter in the query, but it was not that much data, get it into a list, and then cache the result. So this will make sure that this cache can be configured, but the sessions for a conference, they don't change every hour, right? Typically, by the time the conference starts, the sessions are set and nothing much changes there. So I needed to do one thing here, and that's kind of like a native image caveat. This worked pretty well until I built as a native image, and then I got a couple of weird class loading errors that were pointing me to, basically a package outside of Quarkus. So the Quarkus cache uses an implementation for cache created by someone else, Ben Mains. And at that time, so we're talking a year ago, this wasn't fully native image compatible. So this is like a third-party dependency that Quarkus cache depends on. So I needed to instruct the native image compilation that there were a couple of classes that were typically being loaded via reflection. Well, you don't have dynamic class loading in native images, so I need to instruct my native image compilation that it needs to fetch these classes up front so they can be loaded by the cache. So I linked to a GitHub image here. I looked at this GitHub image this morning. This was fixed ages ago already, so I can get rid of this, but I left it in just for demonstration purposes. And that's about, I think, the most amount of trouble you can get in with building native images, that sometimes you will get issues with stuff that you can do in the JVM world, but you cannot do in a native image world. So one other remark is that the connection, so it works pretty much the same locally in JVM mode as native image on AWS Lambda. Even the database, but this is because I've configured the access code for the database in my code. So I'm connecting to the production database from my local laptop, which is easy for development and debugging. Probably not the best way to run in production with your enterprise app, right? So you'd want to set some access roles or something that would allow you to give your application the rights to connect to this database. But it is a nice way, in my case, to simplify moving from local development to production. All right, so some experience from running in production. So this went live summer last year. So we've had JSpring, JFall, and then a couple of weeks Stagnation that will run on this. So let's look a bit about monitoring and stuff. Well, these are some metrics during JFall. So JFall has about 1,800 attendees. We'll look into these graphs in a bit more detail. So number of invocations per minute. So this is how often my Lambda gets called. So the peaks here are about 60, 65 invocations per minute, which is not super much for 1,800 attendees, right? But well, just like you, not everybody is going to pull out their phone during a session or after a session to vote for a session. I hope that you will all do this after this session so I can get feedback from you. But you see that the peak number of invocations is around 60 something. And there's one interesting peak here at about 1650. Whereas over 100 invocations, it's about twice that we saw in the peaks in the rest of the day. So most of these peaks are explainable. So this is probably after the opening keynotes, when there's like 700 people in the room, they all start voting. This is after the afternoon keynotes, but then there's a huge peak here in the afternoon. What's this? I don't know. Could have been that there was somebody who was at a large company and asked all their friends to vote on their session at JFall. Could also be that somebody found out the API and started the script and invoked it 100 times to, I don't know, give himself a big score. So this is obviously outside the scope of this application, but it's interesting insight. The request duration. So this is a 1 minute average. And the green lines here is the maximum duration of requests. So averaged over 1 minute, the maximum duration of requests is almost never above 1 second, right? So that means that the attendees of JFall have typically needed to wait at most 1 second for their vote to be stored, which is, I think, quite nice for something that is a cold start. There's here one peak where it was probably scaling up, where it took like 2 seconds, but this is max. So average is orange, and average is more like 500 milliseconds, lower. Here's more like, I don't know, 10 milliseconds or something. And the minimum, obviously, is like 2 milliseconds, so that's super close to 0. If we smooth this out over an hour, we can see it a bit better. The max is typically under 1 second, and the average is typically around, I don't know, 10, 20 milliseconds or something. A success count, only successes, no errors. Concurrent executions, and here you see some interesting things appear. So there was this peak here in request duration, about like 920 something. So I'm talking about this peak. And we also see that the concurrent execution, so how many Lambdas run in parallel, peaks here. So what happened here? I don't know. AWS Lambda decided to scale my Lambda to 16 instances, which was like the maximum number of instances during the day. So probably, I don't know, number of invocations, it got scared because there was like a big peak here, right? So we're going from almost zero invocations quickly to 40. So probably this was a reaction where it said, more than 40 requests, let's quickly scale to 16 instances, and then back to 0 again. So you do see it scale back to 0 during the day. And there was one more peak here in the afternoon that was around 1440. So let's see what happened there. Yeah, nothing special. So I don't know. But the nice thing is, I only found this out afterwards, because during the day, I don't care. It just runs, and my Lambda runtime makes sure that it scales to the right amount of instances. So logging, you can get logging there as well. You can also see here that a cold start takes 170 milliseconds, and a warm start 2 milliseconds, which is pretty fast. So let's talk about money. How much does this cost? Before, it would cost about, well, let's say 35 for a load balancer and maybe 140 instances, something like 150 pounds, euros, dollars, doesn't really matter, that order of magnitude. What do you think that I'm paying for this now? You can shout. What's the order of magnitude that you're talking about? Are we talking like pounds, cents? Or what's like if you divide a pound in 100, what do you get? Pence. Okay, so are we talking pounds, pences? Pence? We're talking pences? Well, I'm talking I'm talking dollar cents, so that's, I don't know, kind of the same order of magnitude, right? So these are like outside conference week, so we're doing like $3 per month. And then in the conference, it gets almost 3 times as expensive because it cost me $8 to run the whole thing. Yeah, I'm a big spender. So probably this is mostly because of logging, because if you see it's CloudWatch here, and half of the cost is logging. So probably because we get requests in and you pay like, I don't know, a cent per 1,000 requests or something, that's probably most of the cost here. And an API gateway, 1 cent for a couple of thousand requests, almost nothing. And I can keep this running for the whole year now, while before I would shut it down after every conference. So, well, a little bit S3, a little bit CloudWatch, a little bit API gateway. Lambda, nothing, because you have in the free tier, you can do like 1 million requests per month or something for free. So, is this the holy grail or Graal? No pun intended. Well, some caveats. If you need to cross-compile across CPU architectures, this is relatively slow. So it only clicked for me once I went ARM64 to ARM64. You don't have guarantees from third-party library support for native images. To give the example with the third-party cache implementation that I had, but the Quarkus libs are super good, and I think by now most of the open source world has caught up and made everything like native image compatible. Reflection can still be tricky because you can't do dynamic class loading in native images, so you need to pull stuff up front and maybe give some pointers to the GraalVM compiler. Debugging can be a bit painful if the problem does not surface locally. So there's 3 stages. Locally, I'm running in dev mode, just like in JVM mode, but actually is JVM mode. I can make a build and run it locally in serverless mode. I can debug there. But there was one case where it only happened in production on my Lambda installation. And this was when I was trying to figure authentication. And there was a couple of things going on there are a couple of proxies in between, right? So there's the API gateway, there's proxies to the Lambda, and this messed up my headers a bit. So then debugging becomes a bit painful because, well, I need to add logging, do a native image build, deploy, and then do the request again and watch the logging. So this would be like a development cycle of 1.5 minutes every time, like build, deploy. On the other hand, how many of you can go from local code to production in 1.5 minutes? Not many, I think, right? So that's not too bad. It's a good idea to put some limits on Lambdas and API gateways, because if somebody would run a script that would do like, I don't know, 10 million requests to my Lambda, probably will be a bit more than $4 they would need to pay. It's probably good to use build and deploy pipelines instead of doing everything locally and pushing to production. But if it's if you're the only developer and the only operator, who cares? I don't. So let's wrap up. Serverless Java is totally doable in 2024. And Quarkus and GraalVM love doing serverless stuff. It's ideal for small and hobby projects, like my project, but you can totally do this for your enterprise project as well. Obviously, caveats apply there in terms of startup time, etc. So your mileage may vary depending on your project, your dependencies, etc. The project I just showed is on my GitHub repo. Go to github.com/BERT JAN, and there's Quarkus, GraalVM, AWS Lambda, ARM64. You just need to grab an Amazon account, install AWS CLI, AWS SAM, and then you can get started in about 1.5 minutes from now to get stuff running there. I'll wait a bit for the pictures to finish. I'll share the slides on my Twitter. That's it. One more request for you. Well, actually 2 requests. First is please send as many requests as possible to the DevOps app by rating this session. Be honest, but also be generous. And secondly, please go kick some ass with your newfound knowledge. Thanks for your time, and I hope to see you around.